Our planet is sending us a message, loud and clear. It's a story told not in whispers, but in rising temperatures, shifting weather patterns, and melting ice. As a journalist, I've spent decades tracking stories from across the globe, but few hold the universal weight of the climate narrative. The latest data reveals a compelling chapter, showing just how profoundly our world is changing. So how do scientists track this monumental shift? And how do they gather the intelligence needed to understand such a complex system? In Europe, a formidable operation known as the Copernicus program stands at the forefront. It's the European Union's Earth observation component, designed to provide comprehensive, continuous, and free information about our planet. Think of it as our collective eyes on Earth, constantly monitoring everything from our atmosphere to our oceans, and crucially, our climate. Behind the vast network of Copernicus lies a scientific powerhouse, the European Centre for Medium-Range Weather Forecasts, or ECMWF. Established in 1975, this independent intergovernmental organization operates one of Europe's largest supercomputer complexes. It's the brain, if you will, processing immense volumes of data. This allows it to produce highly accurate global weather forecasts. Critically, it also implements the Copernicus Climate Change Service, which tracks our warming world. A significant part of Copernicus's data comes from its dedicated fleet of Sentinel satellites. These aren't just single satellites, they're constellations. For example, Sentinel-1 is for all-weather radar imaging and Sentinel-2 is for high-resolution optical imagery. These satellites meticulously map our land and oceans. Their missions are specific, designed to provide robust datasets, ensuring scientists have a consistent, reliable stream of observations from above. But the view from space is only part of the picture. Copernicus also relies on a critical network of in-situ measurements. These are observations taken on the ground from aircraft, ships, and buoys. Imagine automated weather stations nestled in remote valleys, sensors drifting across vast oceans, or even commercial flights contributing real-time atmospheric data. This diverse collection of ground truth information is indispensable. It feeds into models, validates satellite observations, and fills in crucial gaps. One of the most powerful tools in the ECMWF arsenal is reanalysis. This isn't just looking at new data. It's a scientific procedure that takes decades of historical weather observations, from early thermometers to modern satellite readings, and feeds them into current numerical weather prediction systems. The result is a four-dimensional, consistent picture of Earth's climate going back many decades. This meticulous process, embodied in datasets like ERA5, allows scientists to recreate past atmospheric and surface conditions. This gives us an incredibly clear view of how our climate has evolved over time. When you hear about record warmth, scientists often talk in terms of anomalies. This isn't a measurement of the absolute temperature, which varies wildly from place to place. Instead, it's the difference from a long-term average or baseline period. For instance, if the average temperature for 1951 to 1980 was 15 degrees Celsius, and a year comes in at 17 degrees, that's a plus 2-degree anomaly. This method is crucial because anomalies remain consistent over vast distances, giving us a clearer signal of change regardless of local fluctuations or measurement quirks. And what does this meticulously gathered and analyzed data tell us now? The numbers are striking. The Copernicus Climate Change Service recently confirmed that 2023 shattered all previous records. It clocked in at 1.48 degrees Celsius hotter than the average temperatures of the 1850 to 1900 pre-industrial period. This isn't just one hot year. It's part of a relentless upward trend, with each of the last 9 years ranking among the warmest on record. This pattern, consistently revealed across multiple independent datasets, paints an undeniable picture of accelerating warming. For those living in Europe, this isn't abstract data. The continent is warming at more than twice the global average, making it the fastest-warming continent on Earth. This translates to increasing frequency and intensity of extreme weather events. These range from devastating heat waves that claim lives and spark wildfires, to shifts in rainfall patterns impacting agriculture and water resources. The economic cost is already staggering, with climate-related events costing Europe over €145 billion in just one decade. The data from Copernicus, meticulously compiled and openly accessible, provides the critical intelligence needed for action. It's not just a collection of alarming statistics. It's a detailed scientific foundation that informs policy, drives innovation, and empowers communities to adapt and mitigate. Understanding these changes, based on the rigorous work of EU scientists, is the first vital step in addressing the profound challenges and opportunities that lie ahead for our planet.